VEX VR Basic Commands. So today we will program simple commands in order because computers understand and follow sequential commands. Notice that our virtual robot called Mr. Roboto contains a pen on top. This pen can be colors black, blue, red, or green and can be used up or down. It also has an electromagnet at the bottom to pick up metallic discs, as well as a down eye to recognize lines to follow. There's 4 wheels, each 50 meters in diameter. Those 50 meters will come in handy when we realize that the length of one square is 200 millimeters. So we're looking for four full rotations of those wheels. Up on top, we have bumper sensors on both sides, both right and left. This is for when our robot hits something, those sensors automatically know what to do based on the programming that they have. They also have a front eye and a distance sensor that works with echolocation, similar to how dolphins and bats navigate. It contains a built-in gyroscope or gyro. This location sensing works in 360-degree radius perimeter, meaning that if the robot knows it's going 360 degrees or 0 degrees forward, it's going straight forward. If you program it to go 90 degrees, it'll turn to the right. If you program it to go 270 degrees, it'll turn left. Or if you do negative 90 degrees, it'll turn left as well. And if you want your robot to turn completely around and go in the direction where it came from, that would be 180 degrees. We have 4 key vocabulary terms. The first one is drivetrain. A drivetrain refers to anything with a motor attached to a wheel that can travel, whether it's forward and reverse or turning. The second one is programming language. This is a set of rules in which symbols represent actions, follow step-by-step instructions that a computer executes in order for a project to run. This is basically the instructions that the human puts into the computer so that the robot can follow. They have to be in sequence, they have to be detailed. The third vocabulary term is behaviors. These are actions performed by the robot as defined by the programming language. Behaviors is basically what you put in the programming language. What are those steps? Behaviors can be simple. Behaviors can also be complex. And the last key term is commands. A command is a programming block change to adjust to robot behavior. These commands can be for action, they can be for sensing, they can be for performance, they can be for all kinds of things. These commands need to be in sequence. These commands you can control. So when we get into VR VEX, this is the home screen we're going to get. In the left-hand side, you're going to see circles. These circles are categories and they are color-coded. Anything in the dark blue will be in the drivetrain category. So if we want our vehicle, our robot to move from one place to another, we will be manipulating those dark blue blocks. Similarly, if we are working with anything with a sensor, we will be looking at the light blue, or if we're looking at anything that controls the robot, we will be looking at blocks that are orange, so on and so forth. Next to it, we have a library of commands. These are the ones that are color coded, so we know if they are dark blue, they belong to the drivetrain. These are blocks that we use for movement. There are many kinds of blocks. These are the commands that we will be using. The commands go in the work area. you will notice that there is a when started control block already there. This is the way we start. We always start kind of like how before you change a channel on the TV, you have to turn it on, right? So the when started control command is kind of like the let's get started one. Below it, uh, the rest of the blocks will automatically join there as long as you put them close enough. They will latch. You will hear them click, and that means they are ready to go. How do we tell Mr. Roboto what to do? Mr. Roboto works on computer language. In this case, VEX VR works in a Python typed language, but with blocks. It runs on an input output strategy, meaning that whatever you input into the system is what you will get in the output. Again, the example of the remote control, if you push the volume up as the input, the output will be the speaker on your TV getting louder and louder. These all work on algorithms. The algorithms are basic commands, basic structures, basic instructions that the human inputs into the computer so that the robot can follow them. This is the drive forward for 200 millimeters block. We know that it is a drivetrain block because it is dark blue and it begins with the word drive. The first part tells Mr. Roboto in which direction to go. We have it set at forward. The other option would be backwards. If you want your robot to move in a backwards direction, all you would have to do is hit the drop-down menu and choose the backward command. The second part of your block is the white oval. This is a numeric value. You can input whatever value you want in there, 2, 20, 200, 2000. There's also others that contain alpha values where you can input letters to make words. In this case, we're only using numeric value for this specific block. The third part is describing the units for the numeric value. In this case, it is set to millimeters, which is what we will be using in class. However, if you want to explore with inches, you can do so. And the last part, the white triangle facing the right, is an option to either to stop or keep going. Meaning after this command is done, you can tell your robot that's it. You want them to stop there, or it should continue to the next block underneath. All of these blocks, when put together, will begin a set of instructions, but those instructions happen to a virtual robot. This virtual robot can be seen in the virtual playground. The virtual playground axis icon is the first icon in the upper right hand corner. Virtual playground is allows you to play and replay. It allows you to reset it. It allows you to change playgrounds, which we will see in the next slide. It allows you to analyze data, for example, distance, time, speed, direction, etc. And it allows you to change the camera angles. Camera angles can be either bird's eye view or a 45-degree angle behind the robot. Speaking of the playgrounds, the available playgrounds in here are grid map, number map, art canvas, disc maze, wall maze, dynamic wall maze, disc mover, disc transport, castle crasher, dynamic castle crasher. For the first 2 weeks of STEM class, we will be working with grid map, number map, and wall maze. However, feel free to explore any of the others. You can do so by hitting the drop down menu in the center top. So let's go ahead and try it. We can go to https://vr.vex.com, or simply put vr.vex.com on a search engine.